Okay, this is chapter 8.2. Looks like it says 1 here, but it's 8.2, solving inequalities using addition and subtraction. It wasn't long ago that we talked about equations, and we kind of gave the little concept of having maybe a little teeter-totter, and how this was the equal sign. And to the left and to the right of the equal sign, whatever is there should be balanced on the teeter-totter. So something that makes the teeter-totter stay level. For instance, if x is over here, and we say plus 2, and we have 8 over here, x plus 2 is equal to 8. And we talked about what happens if you take 2 away from this side. It becomes imbalanced, and 8 becomes heavier. But since we need to keep it balanced, we have to subtract 2 from both sides, and that's what we kind of worked on. So if we subtract 2 to both sides, then we have the same sort of thing, but it's a teeter-totter that now has just an x by itself on one side, because x plus 2 minus 2 just leaves x. And on the other side we have 6, because 8 minus 2 is 6. So x equals 6. And we learned that if we want to solve, or if we want to check our work, we can put it back in. So instead of writing x plus 2 equals 8, because if x is equal to 6, we can write 6 plus 2 is equal to 8. And if that's true, then we know that we did it right and that the x actually is equal to 6. But now we're working with inequalities. That's the greater than and less than, or the greater than and equal to, or the less than and equal to. And this is everything that is not equal. So you have this is equal to, and this is like everything on one side, and this is everything on the other. And we really increase the number of correct answers we get. Remember, we just finished a lesson where we might have said that x is greater than 4, and when we graph that, and we put in some numbers, and maybe we count by 2's this time, and we know that these lines go forever in both directions, and we say that x is greater than 4. That means that it's a hollow circle, because it doesn't include 4. It could be 4.1, or 4 and 1/2, or 5 or 6 or 7 or 8, or anything that's pointing this direction on the right side, or larger than 4. Anything greater than 4 is what x is. So is x 8? Yes. Could it be 8? Yes. Could it be 13? Yes. Could it be pi? 3.1415? No. So that's what we're doing, but we're going to go ahead and use the algebra that we've learned in the last chapter and add that into what we're doing with inequalities. So it's going to look just like the algebra, but it's going to have a greater than or a less than sign. For instance, example number 1 is x minus 3 is greater than 1. So we could just start with our number line and say, well, what number works for that? If I have 0, actually, 1, 2, 3, 4, 5, 6, 7, and I just try some numbers. Can x equal 2? Well, if I put that in 2 minus 3, that's negative 1, and that is not greater than 1. Negative 1 is over here, and that's not greater than 1. That's to the left of 1. If it's to the left of 1, it doesn't work. 0 minus 3 is negative 3. That doesn't work. 2 minus 3, that's the one we already did. So 3 minus 3 is 0, and that's still not greater than 1. So what if I put 4 in? If I put x is equal to 4, does that work? Oops, not x 44. X is equal to 4. So this one didn't work. If I put x is equal to 4 in, 4 minus 3, is that greater than 1? Well, 4 minus 3 is 1. And is 1 greater than 1? No. So 4 doesn't work either, but you can see that we're getting there. We all know that anything bigger than 4 will work. 5 will work. 5 take away 3 is 2. 6 will work. 6 take away 3 is 3. So anything bigger than 4 will work. So what we do is we do our same, we can use the same idea that we used in algebra. Where we added or subtracted, or we did the inverse operation. X minus 3 we want to get x by itself, so we're going to add 3 to both sides. So x is greater than whatever 1 plus 3 is. See, minus 3 and plus 3, those kind of get canceled out. But 1 plus 3 becomes 4. So x has to be greater than 4, which means that I don't need this place, which is the 1. Okay, I need this place. It has to be greater than 4. And we kind of saw that as we worked through it. So x is greater than 4. That means that I can draw my arrow this direction. Maybe I should have changed colors. But maybe that's just confusing because it kind of looks a little Christmassy now. Okay, so that's how that works. X minus 3 is greater than 1. Looks like this equation. It looks like x is greater than 4 because we simplified it to look like this. So we just simplify. It's kind of like what we do with fractions. Example 2 gives us some others. Let's see, they say 15 is greater than or equal to 6 plus x. So this time it's just like the teeter-totter again. We want to solve to get x by itself, but 6 here is kind of in the way, so we're going to subtract 6 from both sides. Okay, and 6 take away 6 is 0, so 0 plus x just leaves us with x. Over here on the right side of the equation, 15 minus 6 is 9, because 9 plus 6 is 15. So 9 is greater than or equal to x. But we usually like to write that with x first, and that's one of the things we need to talk about. How do I turn this around? I can put x here, and I can put 9 here. If I read it right to left, I read that 9 is greater than x. And if I were to read this from right to left, I would read this as x is less than or equal to 9. So I need to make sure I turn that around. Notice how I turned it around because the x got switched and the 9 got switched. So the sign needs to be switched as well. If 9 is greater than x, then that means that x is less than 9, or less than and equal to in this case. So this is our final equation, and we go ahead and just draw. Let's see, we'll start with 5, 6, 7, 8, 9, 10. So x is less than 9, so we do a less than or equal to. Since it's less than or equal to, we're going to do a solid dot, and we're going to draw our arrow to the less than direction. Notice it's the same as this is pointing. Okay, very good. That's example number 2. We have to learn how to switch it around so that we get x first, and sometimes it gives it to us the other way around. Real life application, the flea market advertises, this is example number 3, that it has more than 250 vending booths. So a flea market doesn't necessarily have fleas, it's just a place where a bunch of people come to sell their used stuff. So they have 250 booths, places to sell, like a little table set up for people to sell their stuff at, or something like that. Of these, 184 are filled. Okay, write and solve an inequality to represent the number of vending booths still available. So the question is kind of how many booths are left. Okay, so we're going to use some words first, and then we'll change it to math. We have booths filled. And then we're going to add the number of remaining booths, number of leftover booths. Okay, and then we're going to talk about the total number is greater than the total. The total number of booths. Okay, so we have 250 booths available. That's this total. So I could actually just write that in. That's 250. Is greater than looks like this. And we have 184 filled. So that's over here. 184 plus looks like this, and the number of leftover booths. Well, we could write B. B could stand for booths. So 184 plus the number of booths left over is greater than 250. So that kind of works. We're going to let B mean the number that are left. So this is the part we're trying to find out. We're going to let that be B. This is the number already filled. That's what we have. Plus the number that still need to be filled is greater than 250. Oh, let me read the beginning sentence again. I was kind of wondering about the greater than. I didn't know if it needed to be greater than or equal to. But it says that the question actually says a flea market advertises that it has more than 250 vending booths. So we don't really know how many more. Probably not a lot more. Probably like 256 or something. Because if they had like 742, they'd probably say more than 700. But since they said more than 250, we don't know for sure how many it is, but we know it's greater than. So I should have written that into the problem when we started talking about what was going on. Okay, so if we rewrite this, 184 plus B is greater than 250, then we're set, and we just have to do a subtraction problem to get B by itself, where we subtract 184 from both sides. So this cancels out and becomes 0, and it leaves B by itself. So we have B is equal to, it's not equal to, it is greater than 250 minus 84. So that's, we have to carry that one, make this a 14. Okay, so 14 take away 8 is 6. And so it looks like 66. B is greater than 66. And if we think about that, 80 plus 60 is 140. So that's, or 180 plus 60 would be 240. Yeah, that makes sense. 240 plus the 6 and the 4 is equals to 250. So B is greater than 66. So that means that we have more than 66 booths. Now these story problems sometimes just take time, and you have to work them out. That's the hardest of what you have. Everything else is just going to follow things that you already know how to do. Have fun with it.